Okay, so we've got a multi-step equation here in algebra, and I think these tend to be really intimidating because of all the fractions and parentheses. But it turns out, in general, a great first step in these problems is either to distribute and then combine like terms, or multiply by some common multiple in the denominator of the fractions you're given. So I guess we'll try and solve it both ways. So I'll solve it first of all in a way that's more typical, and then I'll kind of get rid of these fractions by using a least common multiple. So let's distribute. Distribute and combine like terms, first great step. So we have negative 4 right here. We're going to distribute that to the numbers inside the parentheses. On the right hand side, we're going to distribute the negative 5 to these terms and values inside the parentheses. And I'm going to rewrite everything as I go, so we have 3/4 r. Now minus 4 times 2, that's just minus 8, right? And then we're subtracting again, so we have minus 4 times minus 1/2, it's positive. 4 times a half is just 2, so it's positive 2r. On the right hand side, we have negative 5 times negative r, a negative times a negative is a positive, so it's just 5r. Negative 5 times negative 3, that's positive 15. And then we have to add in 5/8. So now the general strategy after you've distributed is to attempt to combine like terms. So on the left hand side I have the r values. We have 3/4 r plus 2r. That's just 2 and 3/4 r, right? So that's just a mixed number, right? It's 2 and 3/4 r. Minus 8, that constant's all by itself. On the right hand side, 5r is all by itself, but these two constants are there. We can write that as a mixed number, 15th and 5/8. So now, once you've combined with like terms, after you've distributed, get the variables to one side and the constants or numbers to the other. It doesn't matter which order we do this. But what I'm going to do is bring my variables to the right-hand side. If you think about it, by subtracting 2 and 3/4 r, right? Doing the opposite operation here, we get it to the right-hand side, and we avoid dealing with another negative exponent. If I subtracted 5r from 2 and 3/4, I'd be subtracting more from less and get a negative value. I don't want to deal with that. So here these cancel out. 5 minus 2 and 3/4, right? How do we think about that? Well, it depends what your strategy is. I do 5 minus 2, and that's just 3, right? Minus another 3/4, or like 75 cents, is $2.25, right? So it's $2.25 or 2 1/4, right? R. Plus 15 and 5/8 equals negative 8. Now we've got to get all of these constants of numbers to the left-hand side, and usually if we have a constant like 15 and 5/8, we're adding it, we can just start by subtracting that, right, from both sides. So we have negative 8 minus 15 and 5/8, okay? And that's going to equal 2 1/4. I'm going to write that as an improper fraction. I like to work with improper fractions. 4 times 2 is 8, plus 1 is 9. So that's 9/4r. These cancel out. And we have negative 8 minus 15, so that's minus 23, right? And 5/8. Okay, so I'm going to write this as an improper fraction as well. 8 times negative 23 is negative 1. Well, I know 8 times negative 20 is negative 160. 8 times 3 is 24. So it's negative 184 plus 5. So it's negative 189 over 8 equals 9/4 r. So how do we solve from r? We multiply both sides by the reciprocal of the coefficient, right? We want to get the variable all by itself. This isn't as bad as it looks, as you'll see in a moment. So these two cancel out. 4/8, well, that's just 1/2, right? So that 8 goes away. Does 9 go into 189? Well, 9 plus 8 is 17, plus 1 is 18. So if you add the digits up and you get a product of, a multiple of 9, then 9 goes into it, and 18 is a multiple of 9. How many times does 9 go into it? Well, you can kind of quickly figure out by saying, oh, 9 times 9 is 81. We're trying to get up to 189, right, but just with negative numbers. So we need at least 9 more 9s than that, right? So another 9 times 9 will get you another 81. That brings you up to 162. All right, 9 times 9 plus another 9 times 9, that's really 9 times what? Well, that's 18 nines altogether. So we know 18 times 9 equals 162. But we need to get to 189, so I do this. I do 189 minus 162 is what? Well, that's just 27. And 27 is 3 more nines. So we had 18 nines before. We need 3 more. That's 21 nines. You could check it. 21 times 9 is 189. What just happened? Well, we just realized that 9 goes into negative 189 21 times. So it's really negative 21. And then what we have is 1 times negative 21. That's negative 21 over 2. It's non-reducible, and that equals r. So all that work gets us this value for r. But could we solve it another way, right? Could we have, instead of distributing and then combining like terms and then so forth, what else could we have done? Well, I noticed that the denominator here is 4, and the denominator here is 8. So 4 and 8 have a common multiple of 8. So what I'm going to do is multiply everything by 8. And this is a nice first step. I think it's a relief to get rid of the fractions. So how do we do this? Well, the first term is 3/4 r. So really what we have here, we're multiplying everything by 8. We have 3/4, right, times 8 times r. And what's that? Well, 8 times 3 is 24. Over 4 is 6. So we have 6r. The next term we have minus, right, 4. So it's going to be 4 times 8, and that's 32. We don't have to also multiply the numbers inside the parentheses because they're already going to be multiplied by this 4. So you don't have to repeat that process. On the right-hand side, you have negative 5 times 8, that's negative 40. And again, we don't have to multiply by the numbers inside the parentheses. They're already being multiplied by negative 40. Now 5/8 times 8, well, that's like taking 5, multiplying by 8, dividing by 8, right? So you do 5 times 8, and then divide by 8, and you get 5. Or you can just see that the 8's cancel out, right? So that was our strategy. Multiply by, look at your denominators, and find the least common multiple, multiply it, and you'll always get rid of those fractions. So now we just have to kind of distribute again. And this is the same problem. We're just avoiding fractions. Negative 32 times 2, that's negative 64. Negative 32 times 1/2, it's what? It's positive 16, right? 32 cut in half is 16r equals negative 4 times negative r is 40r, or positive 40r. Negative 4 times negative 3 is positive 120, right? Plus 5. Now we combine like terms. These two equal 125. This is 40r. Then we combine our r terms on this side. 6r plus 16r is 22r minus 64, right? Okay. So now we just want to get our variables on one side. I'll subtract 22r from both sides. And what do we get? Well, these cancel out. 40 minus 22 is going to be what? Well, it's 18r. And then we're plus 125 equals negative 64. Now we just get the variable by itself. We're going to subtract 125 from both sides, right? Okay, these should cancel out. And then negative 64 minus 125, if you think about a number line, if you have negative 64 and we subtract negative 125, negative 125, it's going to be the same thing, right? To figure out what it gets to here, what negative number is that, that's the same thing on the opposite side of the number line. If we had 64 and add 125, we will get the exact same thing, but just the opposite value. We'll get a positive value. So 64 plus 125 is a 189, only it's negative. And here, and that equals 18r. So we solve for r, we divide both sides by 18. And what do we get? Well, these 18s cancel out, and r equals negative 189 over 18. Is this answer different from before? Certainly not. We can reduce. 9 goes into 18 twice, so that's just 2. And 9 goes into negative 189, negative 21 times, which is the same answer that we got before. And here we were just able to avoid the fractions. You know, this is a really, it's not so much a complex algebra problem, but it's complex when you're learning how to balance equations. So try it again. Go back. Start over. Right? Can you solve it both ways? How comfortable are you with this really? And can you do this without video help? Thanks.